The next question of Coaches Starters 117 is equality, etiquette.
Yeah. So the question equality etiquette goes like will be given two integers a b using some operations, or you can see using two operations. We have to somehow make them equal.
Yeah.
And if they became equal, we need to return number of steps. Number of steps. Or minimum number of steps to make them equal. Okay. So what are two operations is if we take operation starts from 1, if I is the operation number, operation starts from 1. If I is even, we can add I. Yeah, no, we can subtract.
If I is even, we should
If
subtract.
I is even,
Yep.
we can subtract I from A or B, not both.
And we should at least subtract from 1 to.
Correct. And subtracting from 1 is necessary.
Yep. Exactly 1.
If I is odd, we have to add odd and add. Same similar. So if I is odd, we have to add I to A or B, not both.
And
exactly 1.
Yep. Exactly one of the numbers.
One of the numbers. So for sample test case, 4, 4. They are already equal, no need to perform any operation, 0 is the output anyway. 5, 4, as I said, operation starts from 1, which is odd. That means we have to add it. Adding into 4 will make it 5, which will be equal. Number of operations required is 1. If we take another test case, which is not from the sample input, that is 4 and 6.
Yeah.
For 4 and 6, let's say for I equal to 1, what we'll do? We'll add, right?
Yeah.
We can add it to 4, it will become 5 and 6, correct? Yeah. For I equal to 2, what do you have to do? We have to do subtraction. We'll subtract from 6, let's say. We'll subtract from 6, it will become 5, 4.
Yeah.
We are just dry running it. Let's say if answer is possible, if it's possible, how many steps required, and if it's possible, is that the minimum options possible, or there can be an optimal approach. Yeah. For I equal to 3, let's say we added 3 to 5, it will become what? 5 plus 8 is 8, and 4 will remain. Yeah. If I equal to 4, even remember we have to subtract it. If you subtract from 4 itself, it will become 4, 4. Correct? Again, this become equal. Number of steps required to make them equal is 1, 2, 3, 4, 4. Yeah. So this is the question. Hope you understood. Now moving forward to the approach. Okay. For this input itself, can there be a better approach, or can there be optimal approach, or can there be a better answer, better than 4? Let's say for 4 and 6 itself, if I was 1, we had to add to something. Let's say we added to 4, it will become 5, 6, correct?
Yeah.
If I equal to 2, we had to subtract it. Let's say we do the same operations on A itself.
Yeah.
It will become 3 and 6 now.
Yeah.
I equal to 3, which is odd, we have to add again. In this case, we'll add to A again.
Yeah.
It will become 6, 6, correct?
Yeah.
So for these steps, for these kind of operation required 3 steps only.
Yeah.
And the answer which we got previously was 4. So out of 3, 4, 3 is the minimum. So 3 will be the answer for 4 and 6, which is the optimal possible.
Yeah.
Yeah. So now I complete the question. So out of 4 and 3, we said 3 is the minimum answer. But is 3 is the minimum answer for 4 and 6? You can try. Try different possible combinations for 4 and 6, where 4 is A and B is 6.
Yeah.
Find out, can there be a better answer, better answer than 3, which we got?
Yeah.
I assume there won't be, but still you will have to try. Okay, moving forward to the constraints. Here A, B can be of 10 to the power 9. Correct?
Yeah.
Within the range 10 to the power 9 and 1. That means performing every operations might not be accepted.
Yeah.
So we'll have to move to optimal approach. Let's see what will be an optimal approach for this.
So in this, the main observation is firstly we want to make A and B equal, right? So the main catch here is for A and B to be equal, their difference should become 0, right? Let's consider difference as the absolute difference of A and B. Right? So now our aim is to make this absolute difference 0. We don't know A is greater or B is greater. It depends on the input. So that's why let's take absolute difference. Now the claim is from the operations that were mentioned, there are two possibilities, right? From the operations. So what we can do is we can either increase the difference or decrease the difference in every operation if we look the operations in this fashion. Right? So when can we increase? How can we always increase or always decrease the difference? Let's see that now. A and B, right? For now, for our convenience, let's assume that A is smaller than B. Then if there is a addition operation, I'll always perform that on A. Addition operations are when I is odd. And if there is a subtraction operation, I'll always perform it on B. So this will ensure that the difference will always reduce, right? So on the greater number, always perform subtraction. On the smaller number, perform addition. Then difference will keep on reducing till certain point. Right? So this way we could show that we can, for every operation, we can either decrease the difference or increase. Now, our aim is to perform operations in such a way that difference becomes 0. And we know that for sure, every I should either contribute to a plus I or to a minus I in the difference, for sure. We can't ignore I because we should exactly add I to one of the. So because we can't ignore I, what we do is, let's say I is 1, we always assume we are subtracting the difference. We perform operations in such a way that difference gets subtracted. So when I is 1, 1 gets subtracted from the difference, 2 gets subtracted, 3, 4, 5, so on till let's say x, right? X is a point where sum of all elements from 1 to x is greater than or equal to difference. And sum of elements from 1 to x minus 1 is less than difference. So x is such a point. Right? This is sum of all the elements from the range. Let's say this, they are inclusive. This is the range, let's say. Now, the claim is sum of elements from 1 to x minus difference. We know that sum of elements is greater, right? Minus difference, let's say this is some factor, right? This is some d value. So now we know that we subtracted d, like we subtracted the complete difference, but we subtracted d amount extra, right? And now the claim is d will always be less than x, right? Why this is so? In the sense, when we considered sum of 1 to x minus 1 elements, it was less than difference. Now when we added the x element, it became more than or equal to difference. So that means for sure the extra delta that is present, which is uh, like sum of elements from 1 to x minus difference, that should for sure lie within 0 to d minus 1 only, right? So because if it was perfectly d, then s of I comma x sum of 1 to x minus 1 would have been equal to difference. Right? So that is why from this analysis we can say d is always less than x. Now the thing is, what we are doing here is, for the difference we are assuming we are always subtracting. We are performing operations in such a way that we are always subtracting the value from the difference, right? Now, here let's see. Basically, when we are performing the subtraction, we are subtracting some extra part. To nullify that extra part subtraction, if we could add some element which was previously subtracted, could we nullify that? We could, right? So now, let's say we know that d is less than x. That means before x, we picked each and every element, right? each and every consecutive element. That means we have all elements from 1 to x available with us. Now, let's say D is even, right? If D is even, what we'll do is, uh, we know what is D by 2, right? If D is even, then D by 2 will be something in the range 1 to x by 2, right? X minus 1 by 2, let's say. It will be something in this range. And it depends on whether x minus 1 is odd or even. So it will be in this range. Now, this 1 to x minus 1 by 2, it is some number which is present in the range 0 to x. It is present in the range 1 to x, right? Because we include each and every consecutive element till x. So now what we can do is, we can pick the element which is d by 2, and previously, let's say d by 2 is for now 2, right? Now, the extra difference that we subtracted was 2 into d, right? Always it would be, it is not 2 into d, it is 2 into some value, right? This is even, that's what we know. So that means previously we subtracted 2 from difference. Now what we are doing, we want to add 2 to the difference. If I want to add 2 to the difference, then what will be the delta change? Delta change will be 2 into 2, right? Why? Because previously we subtracted, now we want to add. That means from minus 2, firstly we should make that 0, then again add a 2. So the delta is 4. So from the current value, we are adding 4 extra. So that's why whenever we want to make any value in this range, to become added value to difference, we should for sure add 2 into that value, right? Add 2 into that value. Then only we could do this. So to add 2 into that, if we look over 2 into any v, that is nothing but an even number, right? So that is why when d percentage 2, that is, if d is even, then there will always exist. Basically, if d is even, then we know d by 2 will always exist. So for d by 2, we could, d by 2 we previously subtracted. Now we could add that. So it would contribute as a plus 2 into d. Yeah, it would contribute as a delta of 2 into d, basically. 2 into d by 2, not d, because d by 2 is irrelevant. Now 2 into d by 2 is nothing but d, right? So it is contributing as d. So now the extra difference that we subtracted from difference, we are adding that back. So the add back value is d. So now can we say that difference becomes 0? Right? So now from this we can see that we need x operations in this scenario. So firstly we proved this scenario. So the scenario is, yeah, we know these conditions are holding true now. And now if d percentage 2, if that is even, then we prove that the answer is x for this, right? Now comes d percentage 2 is not equal to 0. When this extra difference that we subtracted is a odd, right? If it is a odd, then then how can we actually get our value? Can we say that we can just convert this odd to the same even scenario? Once our extra difference subtracted is a even, then we can say that answer is just x, which we proved for this even, right? Now let's try converting the odd to even. Now there are two scenarios. Let's say if d percentage 2 is odd, then for sure I must add the next value, right? Till now we added x, right? Now let's say I'm adding x plus 1 to the, I'm subtracting x plus from 1 from the difference. Then what happens? Then there can be two scenarios. After subtracting x plus 1, our d can become odd. Sorry, our d can become even, or it can remain odd, right? So let's see when it can become even or when it can become odd. So if x plus 1 is odd, then what will our D become? So D is the extra difference. Now we are, for this extra difference, we are adding, that extra difference is odd, and we are adding x plus 1, which is a odd. So odd plus odd becomes even. So once it becomes even, the same scenario applies, this scenario. So here number of operations we need are x plus 1, right? Because we just perform one extra operation by including x plus 1 and subtracting it from difference. And one more scenario is, if I add x plus 1 and if x plus 1 is even, then will the parity of D change? Parity in the sense D percentage. Now the delta will be D plus x plus 1, but still D plus x plus 1 will be uh, will will be odd only, right? Because x plus 1 which we are adding is even. So that is why uh, in this scenario, even x plus 1 operations were insufficient. Now, if this scenario occurs, my claim is when my claim is we should add x plus 2 also. Now, if we add x plus 2, for sure x plus 2 will be odd, right? Why? Because they are conjugative numbers. If x plus 1 is even, then x plus 2 should be odd. So in this scenario, answer will be x plus 2, right? Because after adding x plus 1 and x plus 2, our d plus x1, x plus 1 plus x plus 2 becomes even. And we could just apply the same scenario that we proved for d for the case where d is even, right? So that is, when d is even, we can remove any element from the range 1 to x depending on what is d, because always removing such an element will exist, which we proved. Removing in the sense we can consider that is not subtracted, and we can consider that is added. So from this we could see that we can make any delta d if it is even, extra delta d, which is if it is even. So these are the two scenarios. So as a gist, if we see, find out the sum from 1 to x minus difference. Uh, Here the task is to find this xth point. So let's say if we know xth point, then it's just finding out sum from 1 to x minus difference, the delta that we removed extra. And if the delta is even, then answer is x, right? Because we need to perform at least x moves to make difference 0. If that delta is odd, then we have to then we just saw it's impossible to remove odd difference, impossible to nullify odd difference, as whatever element we remove, which we were previously subtracting, and add that element, that will give us a even value, because that element will contribute to plus 2 into the current value of that element to our difference, right? So that is nothing but a even value. So that is why we can never remove odd from it. So when we add x plus 1, and then the delta becomes like the d becomes odd, then we can say it is the same scenario as the events case. So in this case, answer is x plus 1. And if x plus 1 is also even, then we for sure need to add x plus 2 to make the difference odd, right? So in this scenario, we are adding two extra elements from x. So that is why answer is x plus 2. So this is the casework involved in the question. And in this, there is no minus 1 case, because we can see we can always make any number. And one more way to see why minus 1 doesn't exist is, for if we have two numbers, we can generate either minus, like what we can do is we can add, we just saw for the difference, we could either add some value or subtract some value, right? So for the difference, uh, in case, yeah, for the difference, we can always add value. That is, what we can do is minus 1 plus 2. Let's say we are performing minus 1 and plus 2. These are the operations. Then the delta will be plus 1, right? That means we can always increase difference by plus 1. Similarly, if I do plus 1 and minus 2, this means I'll always get a minus 1. Like with using two consecutive numbers, we can always get a +1 or a -1. So that means because the delta is always 1, we could generate a delta which is 1. We could perform this operation until difference becomes 0, right? Either this or this, depending on the sign, depending on the difference of a minus b. If a minus b is positive, then perform +1 type of operation. Perform -1 type of operation. If it's negative, perform +1 type, ignoring the absolute. So because we could generate a delta of +1 or -1 both, we can say it is always possible to construct such a thing. And yeah, and this is the way to construct such a thing, which we prove. Right? This is the case. Right? Now the thing is, how do we calculate x? Right? So if we look over x, we can observe it is monotonic, right? That is sum of, let's say, if sum of 1 to some mid number of elements is less than diff, then can we say that 1 to any value lesser than mid will also be less than diff, right? And similarly, 1 to higher value of mid will be greater than the current value, current s of 1 comma mid. As it is monotonic, we can use binary search to find such a x. So if we look at the pseudocode for finding x, lower point can be from 0 till difference, right? While equal to h. So we are binary searching for x by t. So if so, this is just sum of natural numbers formula, right? Mid into mid plus 1 by 2. If this is greater than or equal to x, not x difference, then can we say that this could be our x, this could be our x, and we want a smaller x. So we do h is equal to, we reduce the height of the search limit, high of the search limit. Else it is smaller, so we need to increase the lower point of the search limit. So this way as it is monotonic, we could just find our x. Once we get our x, it's just doing case work, which we already derived. Right? So if we look at the time complexity to find x as we are binary section, we can say it's big of absolute of a minus, right? Log of absolute of a minus, log base 2, absolute of a minus. And space complexity, it's just big of 1. All these are purpose. This way we can solve it.